In this video, Properties of Numbers, we're going to be referring back to the vocabulary and use some arrays to help us model those vocabulary words. It's going to be really cool to look at the arrays and be able to tell some special properties of numbers like the odd, even, prime, composite, and square numbers.
Let's use an array to see if we can decide if a number is odd or even. What if we think about the number 6? I can build an array for the number 6 with one row having 6 in the row. Let's try and make an array with groups of 2.
So we're going to take these 6 and not adding any to it, we're going to try to make them in groups of 2. So I'm going to just try to find a pair for each one.
And that worked. So here we have an array for the number 6 with a width of 2 and a length of 3. So we can say that the factors of 6 are 2 and 3, or two of the factors of 6 are 2 and 3. And we can say that 6 is an even number.
Anytime a number has the factor of 2, you will know that it is an even number. That is the characteristic of an even number, is that one of its factors is the number 2.
Let's look at the number 7. Again, we can make an array for the number 7 using one row with 7 in the row, and that shows the factors 1 and 7.
And so now we're going to try to do the exact same thing, as we're going to try to put them into groups of 2 and see if we're successful. So I've run out of tiles to make pairs with, so I cannot say that this is an even number. I have to say that it's an odd number.
An odd number is composed of groups of 2 plus 1. So if you see that one tile that does not have a pair, that's your plus 1. An odd number does not have 2 as a factor.
Let's use that same idea of the tiles and try to figure out if numbers are prime or composite. So let's start with the number 7 that we just used on the previous page. I'm also going to be using a T-chart to put my factors into an organized table. So I'm going to build the 7 just like I did on the previous page.
And again, this shows the factor pairs 1 and 7.
So I'll list those in my T-chart and always put the smaller number on the left. And we're going to try to do the same thing and try to put them in groups of 2 and see if we're successful. That did not work in making an array, so we know that 2 is not a factor. So I'm going to try to put them in groups of 3. That didn't work. So I'll try to put them in groups of 4. That didn't work, so I'll try to put them in groups of 5. Still have leftovers, try groups of 6. Groups of 7 works, but we already knew that. We already had one group of 7. So this number is considered a prime number.
Prime numbers are numbers that have exactly 2 factors, 1 and the number itself.
So you can use this tile method with the arrays to try to figure out if numbers are prime. So let's look at a number that is composite. Let's use 6 from our last page. So I'm going to make a 1 by 6 array. And remember, arrays have to make rectangles. Alright, so this one is the 1 by 6 array. So 1 times 6 equals 6.
And you may remember from the previous example that we were able to rearrange the tiles into groups of 2 And that made an array showing 2 times 3. So 2 and 3 are also factors of 6.
And we could keep trying to do in groups of 3, which is just the same as this, but the multiplication combination. So we actually are finished with this. There's no other factors of 6. And because of that, this number is composite because it has more than 2 factors. Something to note about prime and composite numbers. All even numbers are composite except for the number 2, and I'm going to show you why in a minute. But do not think that all odd numbers are prime, and I'll show you an example of that. By definition, we just said a prime number only had 2 factors. So let's look at the number 2. Let's build the array. So this array is 1 times 2. I can move this, but it still is just the multiplication combination of 1 times 2. It would be 2 times 1. So this really only has 2 factors. So 2 is the only even number that is prime.
Let's look at the number 15. Like all numbers, I can make one row of 15.
So now I'm going to try to put it in groups of 2, but we know it's not going to work because this is an odd number, but I'm going to show you that anyways. Because if it were even, I would be able to put it all in groups of 2 with nothing left over, no extras. So there's that +1 that we talked about meant that it was an odd number. So we can't do 2 as a factor.
I think you can use 3 as a factor though. What if we tried and put the tiles in groups of 3? There we see we've made a rectangle with 3 rows and 5 in each row. We know 3 times 5 is 15, so 3 and 5 are factors of 15. Well, that means 15 has to be composite because it has more than 2 factors.
When you list the factors, you would do 1, 3, 5, 15, because you put them in order from least to greatest, and there's more than 2. That does make it a composite number. So it actually has 2 characteristics. It's an odd number, and it's also a composite number. So those are actually 2 separate terms not to be mixed up, because a lot of you want to say odd and prime, but that's not necessarily true.
Some of you might be wondering about the number 1. The number 1 is a special number. It is not considered prime or composite. 1 only has 1 factor. Just 1 times 1 is 1. So the only factor is 1.
Another thing that makes 1 unique is that it goes into every single whole number. It goes into every prime number and every composite number. So those are the 2 unique characteristics about 1. It's not prime or composite, and it also is a factor of every single whole number.
I'm wondering about square numbers.
If a number is a square number, I'm going to be able to create an array that's going to have the exact same width as its length. So you think about a square. We know the characteristic of a square in geometry is that the sides are equal. So we're going to try to see if some numbers are square numbers.
Let's use the example of 9. I can make an array for 9 using one row with 9 in the row. So 1 and 9 are factors of 9. I know I'm not going to be able to make groups of 2 because 9 is an odd number and 2 is not a factor of an odd number. But what if I try groups of 3? So if you'll notice, that works. We have 3 rows with 3 in each row. 3 times 3 is 9. So we also have made a square. The length and the width are exactly the same. Okay, so a square number is the result when you multiply a number by itself. So if I square 3, I would say 3 times 3 is 9. 9 is the square number.